Okay, so for the refusal of Derek's first law, and to prove that it's wrong, I'm using my basement countertop, a little bit of olive oil or canola oil, and a coin. So Derek's first law basically states that when you slide an object, like so, it eventually comes to a rest. This is due to friction. If I put my hand on the counter and slide it and push down, it's hard because there's a lot of friction right now. So that's why the coin slows down. But Newton's first law actually states that an object in motion on a frictionless surface will continue forever. And I'll demonstrate that on this side where I use the canola oil and I put it on so it's a bit more slippery over here. And I'll push the coin with the exact same force that I did, and you can see it just keeps sliding. And if there was no sinkhole here, it would have kept going across the whole countertop. Do that one more time. One more time. Just kept going. That's because obviously it's not a frictionless surface. There's still some friction. That's why my second attempt didn't go as far. But since I put the canola oil on, it reduced it a whole lot than it did on this side. That's why I come back over here and I do this side. It doesn't go as far as the other side. And I am still pushing with the same force. So that is why Derek's first law is wrong and Newton's first law is correct. That an object in motion will stay in motion at a constant rate, and if an object is at rest, it'll stay at rest until an unbalanced force is applied. Okay, so to talk about Derek's third incorrect law and Newton's third correct law, I've chosen to use two cars to demonstrate this. Derek's incorrect law states that, so we'll use these two cars for example. It states that if this car hits this car, it will hit with a greater force because it is probably 7 times the mass of the small one. So if that's true, if I were to hit this car on the back, this car would not move at all once it hit it, and this car would start moving. But in the case, that is not actually true. When both cars hit, when this car hits this car, they both have the exact same magnitude. This car pushing this way and this car pushing back this way. It's just that this car goes a lot farther because the force from this car and the mass of this car causes it to have a greater acceleration than because the mass of this car and the force of this car, this has a smaller force of acceleration. That is why it only goes a little bit farther. So if we do a quick demonstration right here, line these two up, and I push this car, we'll do another one. If I push this, that one went spectacularly farther than this one did, and that has to do with Newton's third law, that say I push down on the ground, I'm pushing with the same magnitude that the floor is pushing back upon me. So in that case, these two cars hit with the exact same force. It just so happens that that car goes farther because there are two differences in mass which cause a greater acceleration and a smaller acceleration for this bigger car. And that is why Derek's third law is incorrect and Newton's third law is correct. Okay, to prove that Derek's second law is incorrect and Newton's second law is correct, I'll be using this car right here. Derek's second law states that force equals mass times velocity. So we go and try that out. There's no constant velocity with this because it is a balanced force. There's a frictional force slowing the car down, and then there's the applied force, which is I am pushing it. So therefore, Derek's second law is not actually possible because the velocity, constant velocity, always changes because the forces are balanced because of friction and applied. This is why Newton's second law is correct, because it states that force is equal to mass times acceleration. I am accelerating this car when I push it with my hand. There's no constant velocity. I keep accelerating the car as I push it. So therefore, there's always a force acting on the car to have it accelerate. So that is why Newton's second law is correct, which is force equals mass times acceleration, and Derek's second law is incorrect, which is force equals mass times velocity.